Okay, this is the video to replace day 22, and what we're going to do is we're going to do whatever we would have done on day 22, which is go over the homework for day 21, and we're going to then do a lesson. So let's start with the homework from day 21. The first thing I want to do is I want to do a couple of the problems from the worksheet I gave you with the 4 AP Calculus questions. It's 3.4a, AP Calc exam problems for motion. There's 2 multiple choice, and then there are 2 free response. I would like to do one of the multiple choice questions. I'd like to do question 2. Question 1 I want to save maybe for day 23. Okay, if you want to give it a shot, give it a shot. But I'm going to save it for day 23. And then I'm also going to do question number 3. If we have time, we'll try out question number 4, but I have some other stuff I want to get to. So, question number 2 says the position of a particle moving along a straight line at any time t is given by x of t. X of t is equal to t squared plus 4t plus 4. T squared plus 4t plus 4. And it says, what is the acceleration of the particle when t equals 4? So we want to know what a of 4 is, acceleration at time 4. And in order to find acceleration, we're given the position function, so we need the second derivative because acceleration is the second derivative of position. So in order to get the second derivative, we need the first derivative, which is velocity. So the velocity function is the derivative of the first derivative of position, which is going to be 2t plus 4. And now if we do acceleration, the derivative of velocity, the derivative of 2t plus 4 is just 2. And so it doesn't matter what our time is, what our input is, our acceleration is constant at 2, and so the correct answer is option B, 2. Okay? That's question number 2. Now let's try question number 3, which is a free response question. It has 4 parts to it, A, B, C, and D. We'll do them one at a time. So question number 3, it says that a particle moves along the x-axis in such a way that its position at time t is given by x of t. It says that x of t is 3t to the 4th, 3t to the 4th, minus 16t cubed, minus 16t cubed, plus 24t squared, 24t squared. So that's our position function. Part A says, determine the velocity and acceleration of the particle at time t. So basically it just wants the velocity function and it wants the acceleration function. Well, the velocity function is just the first derivative of the position. So the derivative of this, 4 times 3 is 12. T, subtract 1, cubed, minus 48t squared plus 48t. There we go, there's the velocity function. Halfway done with part A. Alright, and then it says the acceleration function, well that's just going to be the derivative of velocity. So acceleration with respect to time is going to be 36t squared minus 96t plus 48. Okay, there we go. That's part A. Part B says, at what values of t is the particle at rest? Well, at rest means stopped, or not moving, or standing still. And that means not moving at all means that velocity, that's where the velocity of the object is equal to 0. Okay, when velocity is 0, it's not moving at all. When it's positive, it's moving to the right. When it's negative, it's moving to the left. And when it's 0, it's not moving at all. It's at rest. So we want to identify all times when velocity is equal to 0. Well, in order to do that, we need the velocity function, which we just found in part A. So velocity, as you remember, is 12t cubed minus 48t squared plus 48t. And to find out where it's at rest, we want to set this equal to 0 and now solve for t. We want to know what t values will make this function equal 0. Well, this can be factored, okay? We can actually factor a 12t out of each one of these terms. So we're going to take out our greatest common factor. So we're going to have 12t times, if we divide each one of these by 12t, this one becomes t squared. This one becomes minus 4t, and this one becomes plus 4. That's equal to 0. Just a little bit of algebra here. And now, you may notice that we can factor this. Okay, what two numbers multiply to positive 4 and add up to negative 4? Well, that's negative 2 and negative 2. So what that is what we got here is we've got 12t times t minus 2 times t minus 2 equals 0. Okay? And a better way to write this, instead of 12t times t minus 2 times t minus 2, well, we could just say t minus 2 squared, and then we only have to write one of them. Okay? And then we can put the 12t right here. So 12t times t minus 2 quantity squared is the velocity. So this is actually now another representation of velocity. Okay, so velocity is 12t times t minus 2 quantity squared, and we're setting it equal to 0. Well, now that it's in factored form, it's a lot easier to identify the zeros. There's two numbers that we could plug into this and get 0. First of all, if we plug in 0, if we plug in t equals 0, that'll make this term, this expression 0, and 0 times whatever this is going to equal 0. So we know that it's going to be at rest at t equals 0. And then the other number we can plug in, if we look at this factor here, we can plug in positive 2. 2 minus 2 is 0. And then if that's 0, then the whole thing is 0. So at t equals 2. So when time is 0, or at time 0 and at time 2 are the two instants at which this object is at rest, because velocity equals 0. Okay, so now let's look at part C. Okay, part C of this question, it says, at what values of t does the particle change direction? Change direction. Oh, this is good. Well, how do we understand direction? What quality of object motion tells us about direction? Well, it's velocity. Velocity is both speed and direction. So it's the sign of velocity. When velocity is positive, okay, if velocity is positive, we're moving right, or the object is moving to the right. If velocity is negative, the object is moving to the left. Changing direction means changing from going right, you stop going right and start going left. Or you stop going left and you start going right. So, what we're looking for here is, when would we know that it would stop going left and start going right, or stop going right and start going left? Well, that means it's going to stop being negative and start being positive. Or stop being positive and start being negative. Well, that happens at 0, right? Okay, 0 is when things stop being negative and start being positive, or the other way around. So, we're actually going back to part B, where we identified our zeros. Okay, so we're going to go back to velocity, and I'm going to put it in factored form like we found in part B, t minus 2 quantity squared, and then we're going to identify where this is equal to 0. And we've already identified that it equals 0 at time 0 and at time 2. Now, this is a great time to introduce to you something I'm going to show you in the lesson part of today for day 22. We're going to talk about what's called a sign chart. And when I say sign chart, I mean not sign like trigonometry sign. I mean sign like, positive or negative. A sign chart. A sign chart basically shows you, it's a very simple, basic idea of understanding what the sign of a function is, positive or negative, at any particular value. And it looks like this. To answer part C here, I'm going to draw a horizontal line, and this is going to have the t values on it, okay? And then we're going to look at whether v of t is positive or negative at various values of t. And the first thing you're going to put on your sign chart is you are going to put your zeros. And we've got a 0 at t equals 0, and we have a 0 at t equals 2. And now what you're going to do is, or what we're going to do, is we're going to take values that are less than 0, between 0 and 2, and greater than 2, and we're going to plug them into our velocity and find out whether velocity is positive or negative. So let's take a number less than 0. How about -1? So we'll plug -1 in here. If we plug -1 here, 12 times -1 is -12. Okay? -1 minus 2 is -3. -3 squared is +9. So we have a -12 times a +9. It doesn't matter what the value is, we just know that a negative times a positive is negative. So all of the values less than 0 will yield a velocity, a negative velocity. And that means that the object all the way up until 0 is moving to the left because it has a negative value. Now, we're going to do the same thing for a number between 0 and 2. How about 1? If we plug 1 in here, 12 times 1 is 12. 1 minus 2 is -1. -1 squared is +1, so it's 12 times +1. 12 times +1 is a positive value. So that means that between 0 and 2, velocity is going to always be positive, meaning it is moving to the right. Oh, look at that. Moving to the left, moving to the right. I think we have just identified one of the places where it changes direction, because it's moving to the left, then 0, then moving to the right. Now, let's look at this last part right here. Let's plug in a +3, because that's greater than 2. If we plug in +3, well, 3 times 12 is 36. 3 minus 2 is 1, +1. Squared is still +1. And 36 times +1 is still a positive value. So, at all the values of t greater than 2, velocity is once again positive. And you might say, well, what do you mean positive and then positive? Well, remember, we can have what's called a bounce. Well, some people call it a bounce. When the multiplicity of a 0 is even, that means that the function does not change, it doesn't cross over the independent axis. It actually kind of comes in and touches it, and then sort of comes back away from it. Okay? And that's what we're seeing right there with a multiplicity of 2. So, do we have a change in direction here at 2? No. It's moving right, then it's at rest, and then it's moving right. At rest doesn't mean it has changed direction. It just means that it stopped going one direction. It's going right, then it stops going right, then it starts going right again. It did not change direction. The only place where this object changes direction, the only time it changes direction, is at time 0, when it's got negative velocity and then it changes to positive velocity. So the answer to part C is t equals 0. Okay? That's part C. All right, now let's look at, let's look at part B. All right, part D says, what is the velocity when acceleration is first 0? Okay? Well, in order to find out what the velocity is when acceleration is first 0, we got to find out when acceleration is 0. So we're going to take the acceleration, a of t, which we found in part A is 36t squared minus 96t plus 48. And we're going to set it equal to 0. Now I'm going to do some factoring here. I'm going to factor out a 12. And so this is now going to become 12 times 3t squared minus 8t plus 4. And now this is going to require a special kind of factoring called product sum factoring. We're going to multiply the front times the first times the last. 3 times 4 is 12. And we got to identify two numbers that multiply to 12 that add up to -8. That's negative 2 and negative 6. And so now we're going to split this negative 8t, or minus 8t, into minus 6t minus 2t. We're going to leave the plus 4, and we're going to bring down the 3t squared. Now this 12 is irrelevant for now, because we just want to know where this equals 0, and that 12 is not going to make this equal 0, so we can ignore that for now. Okay. All right, so now I'm going to use factoring by grouping. I'm going to put some parentheses around here, and then I'm going to put some parentheses around here, and I'm going to kind of shove a plus symbol in there. So now what we have is 3t squared minus 6t plus negative 2t plus 4. I've just sort of expanded it, and now I'm going to factor by grouping. Here, my greatest common factor in this binomial is 3t. So I'm going to take a 3t out. If I divide out a 3t, I have a t left here, and I have a minus 2 here. And then I'm going to have and then here, out of minus 2t plus 4, I'm going to factor out a negative 2. That's all I can take out is a negative 2. So I'm going to take out a negative 2, and that's going to leave a t, and then positive 4 divided by negative 2 is negative 2. And now I have 3t times t minus 2 minus 2 times t minus 2. And this is basically what we're looking at here is t minus 2 is one thing, and it's being multiplied by the binomial 3t minus 2. So this is the equivalent of 3t minus 2 as one factor, and then t minus 2 as the other factor. There we go. Okay? And so acceleration can actually be factored into this, into factored form into these two factors. And if we set this equal to 0, now what we want to do is we've got to set this equal to 0 and this equal to 0. So when we go 3t minus 2 equals 0, we get t equals 2/3. Okay? And then when we do t minus 2 equals 0, we get t equals 2. So acceleration equals 0 at time 2/3 and at time 2. And the question says, when acceleration is first 0. Well, first 0, 2/3 happens before 2 does, right? So this question is asking us what the velocity is at time equals 2/3. So now what we're going to do is we're going to take our velocity, erase all this, and I'm going to use that same velocity that we used before. The factored form is equal to 12t times t minus 2 squared. And now I'm just going to plug 2/3 in for that. So v of 2/3 is equal to 12 times 2/3 times 2/3 minus 2 squared. Okay? And if you work all this out, let's see what I'm going to do here. I got the 12 and the 3. I'm going to cancel the 3 and turn that into a 4. So I'm going to have a 4 times 2. That's going to be 8 times. Here's a 2/3. I'm going to turn that 2 into a 6/3. So now 2 minus 6 is negative 4. So I got negative 4 over 3, and then I have to square it. Okay? And then negative 4 squared is 16. And then 3 squared is 9. And so now I have 8 times 16 over 9. And now 8 times 16 is going to be 128 over 9. That is my velocity at time 2/3. Notice that it's positive, and 2/3 is between 0 and 2. And remember on our sign chart we saw that velocity between 0 and 2, they all have positive values. Well, there you go, positive 128 over 9. That's for part D. Okay. Okay, now we're going to do a couple of the problems from the textbook. Maybe 3 of them. Okay, and if you want more help, if I don't cover one of the questions that you want help with, please come see me, and we'll go over one of them one-on-one. Yeah, you know, I'm here every day from about 7:15 till about 8 o'clock. Before school starts. All right, in the textbook, you're going to go to page 135. You're going to go to page 135, and we are going to look at Let's start with question number 1. It's real quick. Question number 1 says this. It says, write the volume of a cube as a function of the side length. Well, that's easy. The volume of a cube is equal to side length cubed, side cubed. Area is side squared. Okay? So the volume of a cube is side cubed. It's just a formula. That's part A. It tells us to do that. Then in part B, it says, find the instantaneous rate of change of the volume with respect to side. Well, the instantaneous rate of change in volume with respect to side is just the derivative of volume with respect to side. So part B is just going to be V prime, the derivative of volume, okay? Or we could say dV ds, the derivative of volume with respect to side. Well, we can just apply the power rule here, and we get 3s squared. Done with that one. All right, part C says evaluate the rate of change of volume at side equals 1 and side equals 5. So what they want us to do is basically identify the rate of change when the edge of the cube has a length of 1. And then the rate of change in the cube, the volume of the cube, when the edge it has a length of 5. Well, all we have to do is plug those numbers into the derivative. So we'll plug 1 into 3s squared. So 3 times 1 squared equals 3. All right, that's easy. And then if we plug 5 in, we'd have 3 times 5 squared. 5 squared is 25 times 3 is 75. There we go. And then part D says, if S, that means the side length, if S is measured in inches and volume is measured in cubic inches, what units would be appropriate for dV dx? Well, that's real simple. You just take the units of the volume and put them over the units for the side length. So volume is measured in inches cubed per side is measured in inches. So it's inches cubed of volume for every incremental change in inches of the side. So it's inches cubed per inch. So here, this is technically 3 inches cubed per inch. Okay, in fact, down here we'll say inches cubed per inch is the answer to part D. And this would be 75 inches cubed per inch in side length. And that's number 1. Okay, okay, now I want to do, let's do number 2, and then we'll do number 3. That will, well, I definitely do want to do number 2. Maybe I'll do number 3 as a separate video. Let's do number 2 for now. All right, number 2 says this. Number 2 says, write the area A of a circle as a function of the circumference C. Well, this is kind of a challenge. Normally when we write the area of a circle, okay, this is part A, we say area equals pi r squared, right? That's the area of a circle. And that, so, but it doesn't want area as a function of radius. It wants area as a function of circumference. And so I need to somehow or another substitute in for the r something that has a c. I got to substitute something with a c in it. So I'm going to look at circumference, which is 2 pi r, and I want to solve for r so that r is by itself and c is on the other side. Okay? And I'm thinking the best way to do that is just to divide by 2 pi on both sides. Cancel 2 pi, and now look, I have r is equal to circumference over 2 pi. So radius is equal to circumference over 2 pi. And now over here I can rewrite area as pi times circumference over 2 pi squared. Okay, I have substituted in for radius what radius is equal to with a circumference in it. And now I'm going to go ahead and I'm going to expand this out. I don't want to leave it as squared because I want to cancel something. I'm going to cancel that pi. So I'm going to write c over 2 pi again. See, now it's squared, right? There's 2 of them. And now I can cancel that pi and one of these pi's. And all I have left now is c times c, which is c circumference squared, over 2 times 2, which is 4, and there's still a pi left over. There we go. So area as a function of circumference is circumference squared over 4 pi. Okay? That's part A. And now, with that, let's look at part B. Okay? So area, we're going to say part A, area is equal to circumference squared over 4 pi. Part B says, find the instantaneous rate of change of the area with respect to the circumference. So now this is not the rate of change in area with respect to radius. It's the rate of change in area with respect to circumference. So I want A prime of C is going to be equal to, well, I'm going to apply the power rule to this. Okay? If you think about it, this is the same thing as 1 over 4 pi times c squared. I just took c squared out of the numerator. And so now I'm going to take the exponent and multiply it by the coefficient. So 2 times 1 over 4 pi is 2 over 4 pi, and the 2 and the 4 can cancel. This becomes a 2, this becomes a 1. So it's really 1 over 2 pi. So I'm going to have 1 over 2 pi times c. I got to reduce the power by 1, so it's c to the first power, times c. And if I now put the c in the numerator, I'll have c over 2 pi. That's my derivative. C over 2 pi is my derivative of A with respect to C. I can also say dA dC is equal to C over 2 pi. That's the rate of change in area as the circumference changes. Now part C says evaluate the rate of change in area when the circumference is pi and when the circumference is 6 pi. So this is now, this by the way was part B. Okay, that was part B. And now let's look at part C. Okay, we'll leave that. Okay, and we're going to say that dA dC is now equal to C over 2 pi. And so now part C says evaluate when the circumference is pi and when the circumference is 6 pi. So I'm going to plug pi into the derivative for C. So I'm going to have pi over 2 pi. Well, the pi's cancel. That leaves a 1 up here. So that's 1/2. And then over here, if I put 6 pi in, I get 6 pi over 2 pi. The pi's cancel, and that leaves 6 over 2. And 6 divided by 2 is 3. Okay? And now part D says, what would the units be? If C is measured in inches and area is measured in square inches, what units would be appropriate for DADC? Well, that's inches squared over inches. Inches squared of area per inch of circumference. There's your unit. So this would be 1/2 inches squared per inch. This would be 3 inches squared per inch. Okay, that's number 2. Don't have much time left, maybe about 25 more minutes. So I want to do one more problem. I want to do a word problem though. I want to do question number 9. We're going to do 9, and I think that's going to be it for now because I want to still be able to cover the lesson today. All right, number 9, it shows you a graph. It says that this is the velocity of an object that's moving. And this is what the velocity looks like. It's got, let's see, it goes from 1 to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? And it doesn't give a vertical, but it does, this does kind of start up here and go down to 2, maybe kind of equidistant from the axis, kind of just as much negative as it was positive, and it passes through 1 right there. Okay? And then it's flat from 2 to 3, and then from 3 until 6, it kind of goes up to about halfway, maybe right about there. And it crosses over at 5. So it does this kind of. And that's supposed to be a straight line. Sorry about the terrible drawing. And then from here, it goes from here down to 7. And then at 7, it stays on 0 all the way up until 9. That's the velocity of this particular function. And part A says, when does the particle move forward? Then it says, when does it move backward? When does it speed up? And when does it slow down? All right, so part A. Well, moving backward, or moving forward, is positive motion. That means a positive direction. Well, when does velocity move in a positive, or excuse me, when does a particle move in a positive direction? Well, it moves in a positive direction when velocity has a positive value. Velocity has a positive value from 0 to 1 and from 5 to 7. It's above the t-axis. This is a t-axis. Okay, when velocity is positive, that indicates forward motion. So this object is moving forward, forward from 0, for t between 0 and 1, and for t between 5 and 7. 5, oh, I think that's out of the camera's range. So let's just say 0 to 1 and 5 to 7. There we go. Okay, so it's moving forward from 0 to 1 and from 5 to 7. Well, then when is it moving backward? Well, backward, it's moving backward whenever velocity is negative. Well, when is velocity negative? Well, it's negative from 1 all the way up to 5. It's below the t-axis from 1 to 5. So from 1 to 5, and oh, it says seconds. This says that this is t in seconds. Okay, in seconds, so we're going to say seconds. 5 to 7 seconds and 1 to 5 seconds, it's moving backward. Okay. All right. The part A also says, when is it speeding up and when is it slowing down? Well, this is one of the things I was going to talk about in today's lesson, so now's a good time to cover it. Speeding up means that velocity and acceleration are the same sign. So, an object is speeding up whenever velocity is positive and acceleration is positive. Or when velocity is negative and acceleration is negative. So if both of them are positive or both of them are negative, it's speeding up. Well, guess what slowing down means? Slowing down means that velocity is positive and acceleration is negative. Or velocity is negative and acceleration is positive. Okay, so let's look here. Let's look at every place where velocity changes sign, because that's where it goes from positive to negative. From 0 to 1, velocity is above the t-axis, so velocity is positive. Let's put up here, we're going to put speeding up, and then slowing down. Speeding up and slowing down. Well, from 0 to 1, velocity is positive, but it has a negative slope. Acceleration is the derivative of velocity, so it's the slope of velocity. So acceleration is negative, and velocity is positive. So from 0 to 1, the object is slowing down. But starting at 1 and going to 2 right here, acceleration is still negative because velocity has a negative slope, but velocity is below the t-axis. So velocity is negative. So from 1 to 2, velocity is negative and acceleration is negative, so that means that it is speeding up from 1 to 2. Now, from 2 to 3, velocity has a slope of 0, and so acceleration is neither positive nor negative. So from 2 to 3, it's not speeding up, it's not slowing down. But from 3 all the way up until 5, velocity has a positive slope. That means acceleration is positive. Okay, so right here, acceleration, a of t, is greater than 0. Acceleration is positive, but velocity is negative. It's below the t-axis. So right here, from 3 to 5, it's slowing down. So from 3 to 5, it's slowing down. When we get to 5, going from 5 to 6, acceleration is still positive because velocity has a positive slope. But now velocity is above the t-axis. So velocity, let's not write it right there. So right here, velocity is greater than 0, and acceleration is greater than 0. So from 5 to 6, it's speeding up. But then at 6, look what happens to the slope of velocity. It becomes negative. And so the slope from 6 to 7 is negative, so a of t is less than 0, it's negative, but velocity is above. Velocity is greater than 0, it's above the t-axis. So it must be slowing down from 6 to 7 seconds. Okay? And then starting at 7, you can see that the slope of velocity itself equals 0, and acceleration is 0 because the slope is 0. Slope is 0, and velocity is equal to 0, so it is at rest, and so it's neither speeding up nor slowing down. It's not moving at all. Okay? So there you go. There's part A. Speeding up at these times and slowing down at these times. Now, part B says, when is the particle's acceleration positive, when is it negative, and when is it 0? Well, we just went through all that, didn't we, in part A, to identify where it's speeding up and slowing down? Acceleration is negative wherever velocity has a negative slope. So acceleration is negative, a of t is less than 0, from 0 to 2. And it's negative from 6 to 7, negative slope, from 6 to 7. Acceleration is positive, a of t is greater than 0, well, from 3 to 6. It's the only place. From 3 to 6. And then it says, where is acceleration equal to 0? Well, it's from 2 to 3, where velocity has a slope of 0, and from 7 to 9. So, a of t equals 0 from 2 to 3, and from 7 to 9, because velocity has a slope of 0. Excuse me. 7 to 9. That's part B. Part C, when does the particle move at its greatest speed? Well, its greatest speed. Speed is velocity and forgetting about its sign. So speed doesn't care about whether velocity is positive or negative. So, if I'm looking at this graph, speed is the magnitude of velocity. It's the number of velocity. So if velocity is basically, speed is the absolute value of velocity. Speed is the absolute value of velocity. Okay? And so we can ignore the sign, meaning whether it's positive or negative. If velocity, let's say v of v of 5 equals negative 70, and let's say that v of 9 is equal to positive 50. Well, this number is bigger than this number. The velocity is greater. But if we take the absolute value, the speed at 5 is positive 70, and the speed at 9 is positive 50. So when is it going faster? When does it have a higher speed? Well, it has a higher speed at time 5, because the absolute value is larger at time 5. So if we're looking at this graph, when is the graph farther away from the t-axis? Well, it looks to me like the distance here is about the same as the distance here. And so it looks like there's an equal speed here at time 0 and at time from 2 to 3. So it looks to me like its fastest speed, its highest speed, is at time 0. Time 0 and where time is between 2 and 3. That's when it's at its fastest speed. Greatest speed, excuse me. Part D says, when does the particle stand still for more than an instant? Well, we already talked about this earlier in another problem. Standing still means at rest. That means velocity equals 0. Well, the velocity equals 0 in a few different places. It equals 0 here, it equals 0 here, and it equals 0 here over this interval. But it says for more than an instant. That is standing still for an instant. That is standing still for an instant, because it's negative, then at it for an instant it's 0, and then it's positive. But this is longer than an instant. Here, velocity is equal to 0 from 7 until 9 seconds. So the answer to part B is all times from 7 to 9 seconds. The object is standing still for more than a second. That is question number 9. It's a really good question. 9 is a really good question. Knowing number 9, you should then be able to do questions 10 and 11. 12 is a little bit of a bear. If I get a chance, I might do a separate video on question number 12. Okay? Or please, come in. See me in the morning. We'll go over one of these questions. Give us about 15-20 minutes to go over one of these word problems, and we'll do it. Okay? Got about 10 minutes remaining. And in that time, I just want to go over the lesson for today. And the lesson for today, honestly, we've already gone over a bunch of it just doing question number 9 and I think one of the other questions. All I want to talk about today is, here it is. I've got 3 main points I want to talk about. I want to talk about, let's get this one. First one, I want to talk about sign charts. Sign charts for identifying where a function is positive and negative. It's really good for velocity. It's also really good for acceleration and also for position. Sign charts are very useful. I want to talk about speed, which we just talked about briefly. And the third thing I want to talk about, which we did not talk about yet, is average rates of change.
Teacher, please excuse the interruption. Please release all JV and varsity volleyball players at this time, please. Please release all JV and varsity volleyball players at this time.
Okay, so let's talk about sign charts. All right? Let's say that I have some function y equals, let's see, x squared plus 2x minus 3. X squared plus 2x minus 3. If I want to make a sign chart for this function, I need to identify all of the zeros. So in this particular case, and there's several ways of identifying zeros. You can use the quadratic formula, you can use a calculator, you can factor. I'm going to factor this. If I factor this, I'm looking for 2 numbers that multiply to negative 3 and add up to positive 2, and those are going to be positive 3 and negative 1. So I got x plus 3 and x minus 1. And now if I set this equal to 0, my 2 zeros are negative 3 and positive 1. And now what I'm going to do is I'm going to draw a horizontal line. I'm going to put a hash mark for my negative 3. It's a number line basically. I'm just drawing a number line. And I'm going to put a hash mark for positive 1. And now all I want to know is y positive or negative on each of these intervals. By putting these hash marks, I have created 3 intervals. One that starts at negative infinity and ends at negative 3. Another one that starts at negative 3 and ends at 1. And then one that starts at 1 and ends at positive infinity. And all I'm going to do is I'm going to pick what are called test values. Test values. Numbers that are within these intervals that I can plug in to y and find out whether it's positive or negative. So here I'm going to test negative 4. So if I test negative 4, if I plug it into the factored form, negative 4 plus 3 is negative 1. And then negative 4 minus 1 is negative 5. And negative 1 times negative 5 is positive 5. So we know that all the values on this interval are positive. So we're going to put a plus there. Now we're going to pick a number between negative 3 and 1. I like 0. Whenever I can use 0, I like to use 0. If I plug 0, well here, I don't have to use factored form. I'll go back up to the standard form. If I put a 0 here and a 0 here, I know that I'm going to have my y-intercept, -3. So that's a negative value. So between -3 and 1, I know that this function has a negative value. Lastly, I'm going to check the interval at greater than 1. I'm going to pick +2. I'm going to plug it into the factored form. 2 plus 3 is 5. 2 minus 1 is 1. 5 times 1, +5. Also positive, so I know that all the values from 1 to infinity are positive. Which makes sense because this is a parabola. It's a positive parabola, and it has 2 zeros, so it crosses over the x-axis in 2 places. It's negative here, positive here, and positive here. Makes sense, right? Okay, that's a sign chart. And once you have a sign chart, let's pretend that this was velocity. If this is velocity, and those were t's instead of x's, this would be the t-axis, and we would be talking about velocity, we would know that the object is moving to the right or forward from all times less than -3 up until -3. And then from -3 up until time 1, it's moving in a negative direction, which usually means left or backward or down. And then from time 1 on, however high, for however long it moves, it's moving in a positive direction, meaning it's moving to the right. Okay, so that's a sign chart. They're very useful. I'll give you some problems where you can solve them with a sign chart. You can even use sign charts when you're dealing with a graph. Maybe if I get a chance in class on day 23, maybe I'll do a sign chart of number 9 that we just did, and we can just do the whole thing with just a sign chart. Okay. In fact, you can make a sign chart of velocity and acceleration to identify the speed of a function. Now, speed. The speed function is the absolute value. I already said this before. It's the absolute value of velocity. All you have to do is get rid of the sign, positive or negative, of velocity, and you have the speed. So if velocity is -35, the speed is 35. It's just moving at a speed of 35 in a negative direction. If the velocity is +40, the speed is 40 and it's moving in a positive direction. That's all speed is. But the main thing we usually need to determine when dealing with speed is whether an object is speeding. Whether its speed is increasing. Speeding up means that the speed is increasing. Slowing down means that the speed is decreasing. And it's very simple to determine both of these things. At any time, if velocity and acceleration have the same sign, then the object is speeding up. If velocity and acceleration are both negative, it's speeding up. If they're both positive, it's speeding up. Slowing down, velocity and acceleration have different signs. If velocity is positive and acceleration is negative, it's slowing down. If velocity is negative and acceleration is positive, it's slowing down. It is as simple as that. If either velocity or acceleration is 0, then it is neither speeding up nor slowing down. Okay? And that's it for speed. And we'll probably do some examples on day 23 of that. Okay, but I'm coming down to about just a couple minutes remaining. Last thing we're going to talk about is the average rates of change. There's 2 kinds of average rates of change you're going to deal with. The first one is average velocity, and the other one is average acceleration. Okay? Now, this is going to seem it's not as intuitive as you think it is. So, if we want to know the average rate of change in f of x over the interval from a to b, the average rate of change, which is a slope, so it's a derivative of sorts, okay? The derivative is going to be f of b minus f of a over b minus a. You already know this formula. So, if your function is no longer f of x, okay? If you're dealing with a position function x of t, and you want the average velocity, well, the average velocity is the rate of change in position. So you're looking for the average rate of change, or the average velocity is the average rate of change in position. Okay? Because velocity is a rate of change in position. So you want v of t is going to be x of b minus x of a. You have to do the position at b minus the position at a divided by b minus a. So you're going to use values from the position function to get the average velocity. Similarly, if you want the average acceleration, a of t, that's going to be the slope of velocity, right? So we got to do v of b minus v of a over b minus a for the average acceleration. And that's it for day 22. That's it for our lesson. Make sure you do the homework. Don't forget to do the examples, and I will see you on day 23.